This is the first in a series of presentations about soils, about their origin, characteristics, and their manipulation, with particular emphasis on the role of soils in the growth of plants, be they crops, turf grasses, or ornamental and landscape plants. This unit presents an overview of soils. It provides a definition, describes its functions, and explains how soil is formed. Other units deal with the physical, chemical, and biological properties of soil and the consequences of its manipulation for the growth of plants. This unit is divided into three parts. The first part gives an overview of soils and the overall process of formation. The second part describes the parental material for soil and its physical and chemical weathering. The third part looks at the general organization of soil layers as soils mature. So let us consider what is soil. People often refer to soil dismissively as dirt and probably regard it as dead stuff. However, soil is an important part of the living world. Along with climate, it determines the composition and function of the ecosystems that can exist in different areas. As indicated here, soils are complex biological and mineral systems and not just piles of dirt. Plants live in the soil as much as they live in the air. Many, if not most, of the ecological interactions between plants and other organisms occur below ground. Most of the individual organisms in an ecosystem and a large part of the biomass exist in the soil. It is not uncommon to hear the term living soil to describe this material. That soil is thought of as living or as a living entity can be demonstrated by the sheer abundance of life that can be found in a sample of typical Midwestern American soil. This diversity of organisms, along with the plant roots that make up a large part of soil, suggests that soil is an important material that must be thoroughly studied and understood by those who seek to grow plants. The importance of understanding soil has been expressed repeatedly. Philip Kroll, a noted scientist and author, states the following: "The nature of soil is characterized by several basic physical, chemical, and biological properties. The interrelationship between these properties determines the capabilities and limitations of the soil for plant growth and land use application. Knowledge of these characteristics aids in making wise decisions for the use of the soil in a given locality." A definition of soil may be as follows. Soil is a naturally occurring thin layer over the Earth's crust that exists as an unconsolidated porous medium composed of minerals and organic matter, formed by weathering and decomposition processes, that is biologically active and varies spatially across the landscape. This definition encompasses the complex and intricate material that is soil. It is also implied that soils may not necessarily be uniform in their properties or behavior. And this is indeed the case. Consider that approximately 22,000 types of soil have been identified and mapped in the US, and Ohio alone has more than 450 types of soils. While this diversity in soil types is significant, soils do have certain common functions, and this function is significant. Let us consider the functions of soil. The central function of soil from an agricultural perspective, and the one emphasized in these presentations, is its support for plant growth. Soil provides not only the anchorage for plants, but it is also the source of mineral elements, the nutrients, and water absorbed through roots that are essential for plant growth. Soil also provides the needed air for root growth. Plants are affected by and contribute to the physical, chemical, and biological properties of soil. Soils are capable of storing and purifying water. Almost every drop of water in rivers, streams, lakes, and aquifers travels through the soil or flows through its surface. Soils have the ability to assimilate large quantities of organic matter, turning it into humus and returning carbon dioxide to the atmosphere for reuse in photosynthesis. Soil contains a complete food web, including producers, consumers, prey, parasites. Many organisms, from bacteria to mammals, depend on soil directly as a habitat. It's been said that 1 cup of soil contains as many bacteria as there are people on Earth, billions of bacteria. Beyond support for living organisms, soil is also relied upon to support buildings, walkways, and roads, though this will not be a subject of these presentations. Given its many functions, it is no surprise that soil is an important yet vulnerable natural resource that must be managed sensibly so it can continue to sustain plant growth and diverse human needs. If one were to pick a handful of soil in an average agricultural field, one would see that it is somewhat loose and crumbly. Careful observation would reveal the typical components that are easy to recognize. Most natural soils that support plant growth consist of solid material. These are mineral particles and organic matter. The other major component would be air spaces that contain atmospheric gases and some water. The proportion of these components varies among the many soils and is related to physical properties that will be discussed in another unit. The way these minerals and organic materials have ended up as soil is central to our understanding of soil. The questions then are, where do the various soil components originate? How do they come together? This leads us to a discussion of the process of soil formation. The process by which soil is formed is encapsulated by keywords that can be briefly summarized as follows. Natural soils are formed by the action of climate and organisms, plants, animals, microbes, on parent material, rock or material derived from rock, over time. Soil formation is also influenced by the relief or topography of the parental material. As time goes by, soil components are subject to physical and chemical weathering, leaching, accumulation of organic matter, and various chemical and structural changes. Soils are tightly or typically organized into layers described as a soil profile. Let me expand on this soil formation process. 5 factors determine the kind of soil that exists in an area. These factors include pre-existing conditions as well as more active agents of soil formation. Pre-existing factors in soil formation include the parental materials or the minerals that exist in a particular site, as well as the topography or relief of the site. There is much diversity in the local geology that results in the parental material for soil, and there is a similar diversity in topography that can range from jagged mountains to deep valleys to rolling hills or extensive flat plains. Agents of soil formation, that is, factors that work on the material that is available and whose action is influenced by local topography, include climate, the variable local temperatures, prevailing patterns of rain, sun, and wind that can be found across the earth, and also organisms such as plants, animals, and microbes. Again, much diversity exists among these agents of soil formation. The whole process of soil formation takes time, which is considered the 5th factor in soil formation. Time, like the other factors in soil formation, is also variable. Upland soils may be many thousands of years old and form very, very slowly. whereas bottomland soils can accumulate sediment rapidly from flooding and runoff from higher ground, and they may be only a few years old. The formation of soil is an ongoing process, and not just rooted in the past. A good example of this process can be seen in the slopes of Mount St. Helens in Washington state, which erupted spectacularly in 1980, destroying all of the vegetation on its slopes. It took about 4 years, by the spring of 1984, to note the first plants that were beginning to grow in the newly deposited ash, thus contributing to the process of soil formation. This is typical of the ecological process of succession that includes accumulation of soil. So to reiterate, the process of soil formation, climate and organisms work on parental materials as influenced by topography to, over a very long time, give rise to natural soil. Also, over time, the soil components are subject to continuous physical and chemical weathering, leaching, accumulation of organic matter, and various chemical and structural changes. These changes will be presented in parts 2 and 3 of this unit.